Hello guys, welcome on Tesla Adventures. In this video today, we'll be discussing the toughest problems from kinematics, and these problems are from Pathfinder book. So these are the toughest problem of kinematics, and the reason why I'm saying that they are the toughest because they are using the extreme concepts of relative motion in chasing problems. So let us discuss these problems. So in this first question, you can see that there is a cat which is following a rat, and rat is running with a constant velocity of u. Now this cat is moving with a constant speed of v in such a way such that her velocity is always directed towards the rat, which means she is always facing the rat. So let us draw the scenario that let's suppose that this is the, in fact, let us do one thing. Okay, now let us suppose that this is the rat which is going with a constant velocity from origin, and its velocity is u, and cat is moving towards the rat always with a constant speed of v. Now this initial distance between them is L, and obviously cat would move like that, which we have already discussed in the previous video. Now we have to find out first of all the acceleration of cat at t is equal to 0. Now you can imagine the case. The most important thing which you need to observe is the fact that only the direction of cat's velocity is changing, not magnitude. So the acceleration of this cat would be only due to the change of its direction. So let us suppose that in some time, this is the origin, in some time this rat moved by a distance of dx. Sorry. So this moved by a distance of dx, and the velocity vector of this cat changes its direction like that. So you can see that if this angle is d theta, we can say that this is the change in velocity of the cat, dv. Okay. And we know that dv can be written as, this is, let's suppose that this is arc, so dv is arc and it is equal to theta into radius, so this is d theta into v. Now we can write that dv by dt is equal to d theta by dt into v, and this is acceleration, so acceleration is this is d theta by dt into v. Now you can say that this angle d theta is equal to arc, this angle is equal to arc upon radius, so arc is dx and radius is this length which is L, so d theta by dt is equal to dx by dt into 1 by L. So this dx by dt is equal to the velocity of the rat. So d theta by dt is equal to velocity of rat is u into 1 by L. So acceleration is equal to this is u v by L. So this is the initial acceleration at t is equal to 0, the acceleration of cat. Now in the second part, that we have to find out the time in which rat is caught. So this we have already done in the previous video, but let me tell you again that if we draw the motion, then obviously cat is moving like that, and at any instant of time the velocity of cat is towards the mouse. Okay, and mouse is moving with the velocity of u. Let us suppose that this angle is phi. So the approach velocity and the distance between them is, let's suppose, r. So their approach velocity, v approach, will be equal to v minus u cos phi, because this angle is also phi. Now v approach is obviously equal to minus dr by dt because it is decreasing the distance between them. So minus dr by dt is equal to v minus u cos phi. So minus dr is equal to v minus u cos phi into dt. If we integrate both the sides, then the limit of L, in fact limit of R, is from L because initial distance between them is L initially, and finally the cat has chased down the rat, therefore the final distance between them is 0. So this would be L minus 0, and this would be limit would be 0 to t, where t, capital T, is the time in which the cat will chase down the mouse. So it would be Vt minus u integration 0 to t into cos phi dt. So L is equal to Vt minus u integration 0 to t cos phi dt. Now we do not know that how this theta is changing. Neither we have a function of theta as a time. So what should we do? We should not think of solving this term. In fact, we could bypass this term. So let us suppose that to bypass this term, let us use the motion of x-axis. So you can see that initially the x coordinate of cat and mouse was same. The x coordinate of cat was same as x coordinate of mouse initially, because they were on y-axis and it was 0. And finally also the cat has chased down the mouse, therefore final x coordinate of cat will be equal to the final x coordinate of mouse. So I can say that the distance moved by cat in x-axis and the distance moved by mouse in x-axis is same in same time. So the velocity of cat in x-axis at any time of at any instant of time is v cos phi, and velocity of mouse is constant, which is u. So the distance traveled by the mouse is ut in t time, and the distance traveled by the cat would be v cos phi into dt, integrating from 0 to t. So integration 0 to t cos phi dt is equal to ut by v. So let us substitute this term here. So this is L is equal to Vt minus u and into ut by v. So you can see that L is equal to v square minus u square into t by v. So t is equal to Lv by v square minus u square. This is the time taken by the cat to chase down the mouse. Now in the C part, that the acceleration of cat immediately before it chases the rat, obviously you can see that the acceleration when it would chase down the rat would be 0 at that instant, because finally the cat would be moving on this line, this one, like that, and its velocity will become constant, and it would not change the direction either, and obviously speed was constant initially also, so this acceleration of the cat would become 0. So this is the question number 1. Now let us move on the next question. In this problem you can see that there is a dog which is running with a constant speed v, and it is chasing a cat that is running with a constant velocity u. So during this chase the dog is always moving towards the cat, obviously, and at any instant the direction of dog makes an angle theta with the direction of motion of cat. So the scenario is like that dog is starting from this point. At any instant of time, the dog is here and it is moving towards the cat. This is cat. And the velocity of cat is like that. And this is u, and the velocity of dog is v, speed of dog is v. So this angle is given as theta, and the distance between the dog and cat is r at this instant. Now we have to find out the magnitude of acceleration of dog at this instant. So obviously you can see that if we say that, let's suppose this dog has moved by a small distance of dx. So the direction of velocity of cat has changed like that, and this angle, obviously this angle will be theta, and this component, this one, would be dx sine theta. Okay, so dv, first of all let us write down dv, and let us suppose that this angle is d theta. So dv will be equal to arc into radius, and in fact arc is equal to, this is arc, this is change in velocity, so dv will be equal to theta into radius. So theta is d theta, and this is v, which we have already used in the previous problem. Now dv by dt is the acceleration, so dv by dt is equal to d theta by dt into v. Okay, so this is the acceleration, and d theta by dt into v. Now we know that d theta is equal to dx sine theta by radius is r, so d theta by dt will be equal to dx by dt into sine theta by r. This value is u, obviously, because u is equal to dx by dt. So this is u sine theta by r. So let us substitute this value of d theta by dt here. So the final acceleration would be u v sine theta divided by r. So this is the final acceleration. Now let's move on the next problem. In this problem, you can see that there is a particle p which is moving with a constant speed of u on a straight line that makes an angle theta with the positive x-axis. So let us draw this line. So this is the line which makes an angle theta with the positive x-axis, and this is the point which has a height of L. So its coordinate is 0, L. Now at this instant, this particle is moving with the velocity of u along this line, always along this line. So its velocity is constant, and at this instant another particle is moving with the speed of v, which is greater than u. V is greater than u. So first of all we have to find out, this is moving in such a way that it is always moving towards this particle. So first of all we have to find out the time in which this particle will chase this particle. So we know that its trajectory would be like that. Okay, which we have already discussed in the previous problems. Let us draw it again. So let us draw this figure, and this is the line. This distance is equal to L, and it is moving with the constant speed of u. Its speed is v, and it is moving like that, in such a way. So you can see that at this instant of time, if we draw the direction of v, then it would be like that, and this particle is here. So the speed of this particle is u, and the speed of this one is v. So let us draw this line. Let us draw a line which is parallel to this line, like that, and this line makes an angle of theta. This is theta with the x-axis. Now let us suppose that this angle is phi. So we can see that the approach velocity, v approach, is equal to v, and this is u cos phi. So v minus u cos phi is the approach velocity, and approach velocity will be equal to minus dr by dt, where r is the relative distance between them, because r is decreasing. So minus dr by dt is equal to v minus u cos phi. Okay, so you can see that dr with a negative sign is equal to v minus u cos phi into dt, and integrating both the terms, the limit of r would be, see, initial distance between them was L, and finally it became 0, so time is 0 to t. So L is equal to Vt minus u integration cos phi dt, limit is from 0 to t. Now again we have to bypass this term cos phi. So let us see that initially this is the perpendicular distance, so this point is M. So in the time you can see that in the time when they are meeting at this point, then the distance traveled by this dog or this particle which is chasing, and the distance traveled by u is, so distance, let's suppose that this point is P. So the distance traveled by the particle, this particle is, let us suppose that this is initially A point and this is point B. So the distance traveled by this particle is AB, particle distance by 1, distance traveled by particle 1, okay, is AB. Okay, and the distance traveled by the particle 2 along this line, distance traveled by 2 along this line will be this one, MB. Okay, M to B in the same time. So this distance MA is equal to L, this angle is theta and this angle is also theta. This is L, so this is L cos theta and this is L sin theta. So MB distance is equal to L sin theta plus AB. Okay, and this distance AB traveled by this particle would be equal to UT. Okay, so I can say that the distance traveled by this particle which is chasing the first particle is MB, and MB will be equal to the component of this velocity along this line is V cos phi. So MB is equal to V cos phi into dt, integrating from 0 to t, and that MB is equal to L sin theta plus AB, L sin theta plus AB, and AB is UT. So integration 0 to t cos phi dt is equal to L sin theta plus UT divided by V. So let us substitute this value in the equation. So L is equal to Vt minus L is equal to Vt minus U into this one. So this is L sin theta L sin theta plus ut divided by v. Okay, so So you can see that this is VL. We have to find out T. So VL is equal to V square T minus UL sine theta minus U square T. So V plus U sine theta into L is equal to V square minus U square into T, and T is equal to V plus U sine theta into L divided by V square minus U square. So this is the time taken by this particle to chase down the first particle. Now let us move on the third part of this question. In the third part, you can see that if the speed of chaser and who is being chased is equal and u is equal to v, then we have to find out the minimum distance between them and what will be the maximum magnitude of acceleration of the chaser. So let us draw the scenario once again. Let us see that again we are drawing the diagram. This is the case, and that particle is moving like that. So you can see that its velocity is v and it is going with u, and at some time it is moving towards this particle, and now in this case u is equal to v. So this is the motion, this is u and this is u. Now again let us draw a line which is parallel to this line like that, and this angle is phi. So this is u cos phi. Now now let us suppose that this distance is r, and the component of this distance is this one is r cos phi. Let us name this point as let us draw the perpendicular. This is A, this is B, this is C, this is D, and this is E. Okay, so you can see, first of all, you can see that their relative distance at this instant of time is L, and initially it was, in fact, this is R, and initially it was L. So we approach, you can see that the V approach is equal to this is u minus u cos phi, which we have already discussed. This is u cos phi. So V approach is minus dr by dt, and minus dr by dt is u minus u cos phi. So minus dr is equal to u minus u cos phi into dt, integrating both the sides. The initial distance between them was L, and finally it is R. So changing the limits, it is L minus R is equal to 0 to, this is 0 to t. So this is ut minus u integration cos phi dt. Limit would be from 0 to t. Okay, so this is the equation number 1. Now let us see that along this line, this line is AE. So along AE, the distance traveled by the second particle is AE. S2 is AE, and distance traveled by the first particle at this instant. In fact, we are talking about this instant. So the distance traveled by the first particle is this one. Okay, this distance. So let us suppose that this is x. So x, this is the distance traveled by the second particle, and the distance traveled by the first particle along this line is equal to BE. S first is BE. Okay, now you can see that this at time t, BE, distance BE will be equal to ut, and this distance x will be equal to this complete L sine theta. This let us suppose that this complete distance is ut plus AB. So AE is equal to UT. AE is equal to UT plus this is L sine theta. L sine theta or L sine phi. In fact, theta. So AE is equal to AB, which is L sine theta, plus this is UT. And we have to find out this distance, AC. So we can say that the velocity of this particle along this line is V cos phi, U cos phi, and we can say that this x is equal to, carefully you can observe carefully that x is equal to AE minus R cos phi. AE minus R cos phi. This is AE and this is R cos phi. So AE minus R cos phi is x. Okay, so AE is UT plus L sine theta. So UT plus L sine theta and minus R cos phi is equal to x, which is the distance traveled by this one. And its velocity is U cos phi along this line, and in time t it has traveled a distance of x. So this is equal to x, and x is equal to U cos phi into dt, limit from 0 to t, small t. So U cos phi dt 0 to t is equal to t, or we can just substitute this value completely in the equation which we have obtained already in this one. So L minus R is equal to UT. L minus R is equal to UT minus this one. So minus this complete term, which is UT plus L sine phi, L sine theta minus R cos phi. So you can see that L minus R is equal to R cos phi minus L sine theta. So we have to find out R. So L1 plus sine theta is equal to R1 plus cos phi. So R is equal to L1 plus sine theta upon 1 plus cos phi. Now you can see that to minimize this distance for R minimum, phi, theta is constant. So there is no variation in theta. So phi should be equal to this cos phi should be equal to maximum, which is 1. So phi is 0. So you can see that R minimum is equal to L1 plus sine theta divided by 2. This is the minimum distance between them. Now let us move on the B part, which is the acceleration, maximum magnitude of acceleration of Q. Now to find out this maximum magnitude of acceleration, let us again draw the diagram for better understanding the concept. So this is the case, and this is V, and this is, in fact, they both are U. So this is also U. So you can see that it would go like that, and we know that at any instant of time, if it is chasing this one, so this would be the direction, and it would not be able to chase down the particle because their speed is equal. So now we know that already we have derived that R is equal to L into 1 plus sine theta by 2. This is the minimum distance, and which at any instant of time this is r minimum, and at any instant of time r is equal to L into 1 plus sine theta by 1 plus cos phi. This is r instantaneous, which we have already derived. And we have already derived the acceleration in the previous problem, that acceleration is AV uv sine phi by r, which we have already derived in the previous problem. So in this case, u is equal to v, so a is equal to u square sine phi by r. So now let us use these two relations. So a is equal to u square sine phi by r, and r is equal to L into 1 plus sine theta divided by 1 plus cos phi. This is 1 plus cos phi. Now to maximize this acceleration, we have to identify that u square, L and sine theta are constants. So dA by d phi sorry, so dA by d phi is u square by L 1 plus sine theta, and d by d phi of sine phi into 1 plus cos phi. Okay, so let us concentrate on this differentiation only. So sine phi, using u into v, sine phi into minus sine phi and plus 1 plus cos phi into cos phi. Okay, so this is equal to 0. So you can see that minus sine square phi and this is plus cos square phi plus cos phi is equal to 0, and cos square phi minus sine square phi is equal to cos 2 phi, and that is equal to minus of cos phi. Now if you can see that if cos 2 phi is equal to minus of cos phi, then this phi would be equal to 60 degree, which I have already calculated to save some time. So this is pi by 3. So let us put this value into the acceleration. So let us see that a is equal to u square sine 60 divided by L into 1 plus sine theta divided by L into 1 plus sine theta and multiply by 1 plus cos 60. So this is u square into root 3 by 2L into 1 plus sine theta, and this is 3 by 2. So you can see that this is 3 root 3 u square by 4L into 1 plus sine theta. This is the maximum acceleration of this particle in the chasing. Thank you.